Let's go. Today, take two, by the way, but fortunately you don't have to listen to take one. All right, we're doing 5.3 sum difference identities, and we are picking up where we left off on Friday. On Friday, we went through this elaborate proof of why the cosine of u plus v is equal to cosine u, cosine v minus sine u, sine v. And if you reverse the sign and make it cosine u minus v, you just reverse the sign over on the right side and you get cosine u plus v. Our goal today is to figure out what is the sign. Is there a formula for the sign of u plus v, and for that matter, the sign of u minus v? And the easiest way to solve this, although it may not look that easy, is to use the cofunction identity. And that says, if you remember, the sine of x is equal to the cosine of 90 degrees minus x, or pi over 2 minus x, whichever you prefer to write. So when I take the complementary, oh poor Jenna, the complement of x and get pi over 2 minus x, I also have to take the cofunction, change it from sine to cosine. Here's what it looks like when we're trying to find sine of u plus v. This says that the sine of u plus v is equal to the cosine of pi over 2 minus u plus v. All I'm doing is saying that u plus v is our x, and so it becomes pi over 2 minus x. Everyone okay with that? All right. Now, pi over 2. Now, what I want to rewrite, though, is I want to rewrite it like this. Let me move this down so you can see what I've done here. I am actually going to rewrite this and distribute the u plus v and rewrite it as cosine of pi over 2 minus u minus v. And I'm going to call the first part here my u and my second part as the v when I go through the formula. And now I'm going to use the cosine formula on that, and we get cosine pi over 2 minus u times cosine v, first term, second term.
So that's not formula, right?
Reverse the formula, plus sine pi over 2 minus u, first term is pi over 2 minus u, second term is v, sine v. One more step and we're done, and you'll have the formula. All this says is that the sine of u plus v is equal to, now, the first term, cosine of pi over 2 minus u. I'm going to use the cofunction identity and change it back to sine.
So this is the actual.
This is it. This becomes sine u.
Okay,
The cosine v stays cosine v.
so that's the formula.
The next term, sine, becomes cosine u. And the last term stays the same. You bet.
Oh, is that it?
That is the formula. And if this had been minus to begin with, it would be minus here. So I want to compare that formula to the very first one we had.
Don't change.
I'm not going to move anything. Go.
Why, when you change it to cosine pi over 2 minus u minus v, why is it like cosine of negative v?
No, the minus sign is in between the two terms, just like it was u plus v. That's my u minus v. It's a u minus v. I mean, I could, and then you'd use the odd even to factor it out. That would be, when I get to minus v, that would be cosine minus v, which is the same as cosine positive v. And this would be sine minus v, which would be the same as minus sine v, and the minus would still come out front. But it would be a minus, so, yeah, I mean, you could still do that, but it's just easier to put the minus sign here. All right, I want to write the two formulas from scratch again. It says this. The first formula you learned was cosine u plus minus v equals cosine u cosine v minus plus sine u sine v. The sine formula, on the other hand, looks like this. Sine of u plus or minus v equals sine u cosine v plus or minus, notice the signs stay the same order, sine v cosine u. So cosine formula uses two cosines in the beginning followed by two sines. The sine formula alternates sine cosine starting with the first term going to the second. Okay, so here are the kinds of problems you can solve with this. First of all, I'd like to prove the cofunction identity and show that it's consistent with what we just learned. All right. So if you've got the cosine of, say, theta, or let's rewrite it this way. Cosine of pi over 2 minus theta. The formula says that this is, using the cosine formula, cosine pi over 2, cosine second term, which is cosine theta, reverse the sign, plus sine pi over 2 sine theta. And that's just what the formula says. If you evaluate each term there, what's the cosine of pi over 2? Oh, wait. Pi over 2 is 90 degrees. Oh, gosh. Please don't pull out your calculator for that one.
Wait, cosine of pi over 2 is the same as cosine of 90, so what would be cosine of pi over 2?
I'm going to pause the recording for a second. Okay, so the cosine of pi over 2 is just 0. That's still cosine theta because I have no clue what theta is. But 0 times anything is 0. Now, what's the sine of pi over 2?
1.
Very good. What's 1 times sine theta?
Sine theta.
Sine theta. So it's plus sine theta. 0 plus sine theta is sine theta. Now, let's look at this again. Cosine of pi over 2 minus theta is equal to sine theta. But that's what you've already put in your notes from long ago. That's the cofunction identity. You knew that the cosine of pi over 2 minus theta is equal to sine theta. You switch to the complementary angle, theta, and your function goes from cosine to just plain sine. This proves it. Or at least it's consistent with it. Let me put it that way. So what are some typical problems that you're going to have with this? They're going to come in 2 flavors of variety on my quizzes and tests. Yep. Flavor number 1 is the fun one. Yeah. I give you some complicated formula, and I need your 2 favorite numbers between 0 and 90.
72.
And an 11. So I write something like this. Cosine 72 cosine 11 minus sine 72 sine 11. And I give you this challenge just to be interesting. You can only push your calculator button. You can only do one function on your calculator, and I've written 4 problems up there. To do this, you would have to find, on your calculator, you would have to find what is the cosine of 72, what is cosine of 11, multiply those 2 numbers together, then find the sine of 72, sine of 11 degrees, multiply those 2 numbers together, and then subtract that one from this one. A real pain.
So all you do is just look up cosine and then 72 plus 11. Cosine.
Yes. Yes. Shelby's got it. Say it again, Shelby.
It's just cosine, and then when the parentheses pops up, it's 72 plus 11.
This is the same as cosine of 72 plus 11.
Yeah.
See, that's the trick. You recognize this as just being it's just the cosine addition formula. Because it was a minus here, we have to put a plus, but this is exactly what this would say. So if you want to enter it just once on your calculator, you would just say, what's the cosine of 83 degrees? And you'll get the correct answer. So we'll try it. Cosine of 83 is excellent. Now let's try the hard formula, which is the harder calculation. So we'll go cosine 72, parentheses, cosine 11, parentheses, minus sine 72, oops, 72, parentheses, sine 11 degrees, parentheses, hit the enter key, same number, a whole lot more work. So I'll give you a problem that looks like this, or maybe it looks like this. Give me your two favorite numbers now.
9,
Yeah.
4. 9, 72.
Okay. Okay, well, yeah, why is it 72 plus 11 minus, and the cosine formula flips the sign? The sine formula does not. So,
How do you know when we are solving for cosine, we use that cosine formula? Because I don't see how that format is like.
Because the other format has pi over 2.
you'll either be given a problem that has two cosines in a row followed by two sines, or sine, cosine, sine, cosine.
Oh, okay.
And I'll give it to you one way or the other on that. So like this one, for example, if I said, what is the cosine of 42 sine, what's your other favorite number? 53. Oh, that's interesting. And I'll put a plus sign this time. Cosine, you know what, I've just reversed these two, but it doesn't matter. Cosine 53 sine 42. The way I wrote the formula, I wrote sine first and then cosine, but it really doesn't matter. When you see cosine and sine followed by each other. Thanks. Oh, okay. You did figure it out.
Does it matter which one of you is going to be?
No.
So it can be cosine U, sine B, or...
Yes.
We'll have to go through.
And I actually, you know what? When I wrote this on the board, I should have written it just like the formula. I should have said sine 50. Yes. I could have written it like that, and it would really match the formula a little more closely. And you're right. This is the sine of 53 plus 42, which equals the sine of 95 degrees, of course. And I'm not going to take the calculator out and do all of that. All right, here's the second way these problems, well, yeah, there are three ways problems can be used. That was method number one. You see a formula sort of written out, and you can shorten it, because I don't know what kind of job you would have where you would have that formula written out like that. You don't really even see it very often in calculus. But yes. And the trick with this one is you know, or should know, what the sine, cosine, and are of these angles. 0, 30, 45, 60, and 90. So I give you a problem like this. I said, what is the sine of 15 degrees? That may actually be your homework problem tonight. I don't remember. And you're going, I don't know what the sine of 15 degrees is. And I say, not only that, you can't even use your calculator to figure it out. Instead, you have to write 15 degrees as the sum or difference of two of these numbers on the board. Okay, and you could pick either 60 and 45 or 45 and 30 and get the right. You'll get the answer either way. So let's say, which one did you want to use, Hannah? 45 and 30? We can write this problem as 45 degrees minus 30 degrees because that's the sine of 15 degrees, 45 minus 30. And now we can write the sine addition difference formula out, and that becomes sine 45 cosine 30, keep the sign because it's the sine formula, minus sine 30 cosine 45. Now it's going to be unit circle practice time. Let me draw the unit circle on here for these two angles so that you can see it. There's 30 and there's 45 degrees. Let's get the x and y coordinate because the x and y will tell us our sine and cosine. Does anyone remember either one of those?
Radical 3 over 2 and then 1 half.
Outstanding. Y'all were just confused before on what I was asking. Because I was not happy. Okay. I was like, I was so sad.
You would talk about it, I was like, what are you talking about?
Yep. So those become the sine and cosine because sine is your y and cosine is your x. And of course that's xy. Okay, so we end up with sine 45 y cosine 30 minus sine 30 1/2 cosine 45 square root of 2 over 2. Now, if you've forgotten your square root functions, properties, when you multiply square root of 2 times square root of 3, it's a square root of 6. 2 times 2 is 4, multiplying fractions. 1/2 times square root of 2 over 2 becomes square root of 2 over 2 times 2 is 4. If you want, you can simplify this down to radicals. Yeah. Yeah, I'll get out of the way. And so that's method number 2. And it will always involve numbers that can be created from 0, 35, 45, 60, 90, parts of the unit circle that you've memorized. Now, let's face it, reality, if you get sine of 15 degrees, you're going to take your calculator out and say, why do I want to go to all that trouble when it's just sine 15 degrees? And there you go. Now, if you want to work with radicals, fine. You'll have it. And that, if you plug that into your calculator and said, what's the square root of 6 minus square root of 2 all over 4, you would get the same answer as we just did on the calculator. So it's kind of interesting. But, all right, method number 3 is if you're dealing with variables. Yep.
For the variables,
Mhm.
you just like take them out and they're not there.
Oh, you just treat it the same way. All right.
Are we gonna have to do the second time?
Yes, but easy like this. As a matter of fact, this may be your homework problem. If it's not, it'll be something very similar, like 75 degrees, 30 plus 45, or 105. 30 would be crazy because you already know 30. Right. So it's going to be something like 15 and that sort of thing. Let me pick a problem like our homework. Okay, I'm going to do a very similar one to our homework problem. I'm actually going to prove an identity for you. And it turns out that's going to be equal to 2 cosine x cosine y. This is sort of a fun little proof. I'll give you a minute to work on it before I put the answer up. All right, we're almost done. So when you apply the rule for the sum or difference of cosine, you get the two numbers in red, or two expressions in red and then blue for each part of this.
Okay, yeah, the sign swap.
And exactly, you see what happens. The signs cancel out, and we're left with two of these cosine x, cosine y. Don't worry, the formulas we're about to come to tomorrow, I promise you, they're going to be more useful, and you will use them in calculus. So, yep. Well, not in life, calculus. Well, calculus is no. All right. So, our homework tonight. Yeah, I know. But I'm going to give you the next 15 minutes of class to do it. We're going to work on page 468, number 3, 5. I want to remind you that on 5, I think they have pi over 12. Yeah, that's 15 degrees. So 3, 5, 12, 19, 47, and that's our lesson.